Usually when we hear about the OSI model, we think about network engineers and we say, I don't want to learn this thing. What is this OSI model? It's all conceptual stuff. Open system intercommunication model. Sounds like a made up name. So I'm not going to learn it. Front-end engineers, back-end engineer, most people don't really care about that stuff. And unfortunately, I learned the hard way that this is one of the most important things that every engineer should really understand and learn. Doesn't matter if you're running Wireshark and sniffing into your packets, or you're executing GET requests from your Axios library, right? I think every engineer should learn this because it will give you more understanding of what really happens under the hood of your beautiful packet that you send, beautiful REST request or POST request in HTTP, or when you connect to a database. What really happens? And once you understand that layers, these 7 layers, you don't really have to understand the 7 of them. Just understand the conceptual abstraction of these layers. It helps you build fundamentals and first principles that you can use to get better understanding of literally anything on top of that model. That include any protocol. You'll start thinking with regards to this protocol, to this model, and you will essentially have better understanding, and you will talk through things way better. You will not be hidden behind abstractions that you don't understand. So in this video show, I want to kind of go through the OSI model and kind of illustrate these 7 layers as fast as possible. So keep the episode short and sweet. How about we jump into it? Guys, welcome to the Backend Engineering Show with your host, Hussein Nasser. By the way, guys, if you're watching this on YouTube, I actually have an audio version of these that is available on Apple Podcasts, Spotify, pretty much all the popular audio. You can literally download that, and any podcast player plays my show. So go find it. It's called the Backend Engineering Show with Hussein Nasser. I think if you search, you should look it. If you can't find it, go to husseinnasser.com/podcast, and you'll find links to all possible RSS feeds to get you to the show. With that said, I want to talk about the OSI model. Hussein, why are you talking about something that has been invented like 300 years ago, right? We're in the age where we talk about fancy stuff and modern tech. We're all about modern. What are you talking about ancient stuff? This ancient stuff is old and boring. You know my opinion about modern tech, quote unquote modern tech. These are built on top of these things that we call ancient, unfortunately. And we don't understand the ancient stuff, despite everything is built on top of it, unfortunately. So that's what I want to talk about here. So let's start with how the networking aspect was even possible. How is it that I was able to transmit information across different machines? How did I start doing that? It began with the invention of someone so smart decided, so if I can somehow sneak in 1 or 0 as bit, this binary representation, which is what computers understand, into physical mediums. What the hell does that mean? Into physical mediums. I'm talking electrical. We started with electrical. So if I can sneak in that 1 or 0 into electrical current or voltage, I would have been succeeded, right? And they managed to do that. They created this concepts. Okay, if I'm making things up here, obviously, but if like if the voltage is 5 plus 5, that means this is a positive. This is 1. This is a bit 1. If it's a negative 5, that means a 0. Again, I'm making numbers up, but you get the idea. So they made up this idea of, okay, they managed to sneak up this bit inside the electric cable. And then if you sneak 1 bit, you can sneak 2 and 3 and 4 and a byte, a whole byte. And if you sneak 1 byte, you can do all sorts of, you can do 2 bytes, 1 kilobyte, 1 megabyte. And you get the idea. Obviously, it becomes the wild, wild west, right? We don't have a system, right? You can just add arbitrary bits. We need a standard. Like, what does that mean, these bits, when it arrives at the other end? How do the other machine kind of know where the information starts, where the information ends? And we had all sorts of other problems too, like, you know, voltage is not, it attenuates as it goes through the cables, so you lose power as a result. You put a bit as 1 and flips at the other end, and it creates chaos. So we needed some sort of a standard to fix these kind of bad things that can happen. But that's just one thing. A lot of smart people decide it's okay, you know what, there's just not one physical medium. We can transmit these bits into radio waves. That's how a Wi-Fi and Bluetooth was invented, right? So if I can sneak into radio wavelength, if I can sneak these bits into wavelength in a sum of a wavelength of a frequency, right, I get the same effect, right? And if I sneak in 1 bit, 2 bit, a byte, you get the same idea. So now we have the logical model of bits and bytes and symbols, and the physical medium is changing. Beautiful. So I don't care what's underneath me. It could be Ethernet electrical cable, or it could be electrical current and electricity, or radio wave, or recently we even managed to sneak in, modulate information into light itself. The fastest thing, particle, is a particle or a wave? People don't know yet. This is a very good question. Is a light particle or a wave? I don't know, I'm not a physicist, but I think people are still figuring this out. They managed to sneak in these information into the light. Thus the fiber optics cable. So fast, right? The same idea, it's like wavelength, right? I don't understand the logic behind this because, again, I'm not a physicist, but that was the breakthrough here. And now our job as engineers is, okay, those physicists did their job, say, okay, right? I don't know if the physicists invented this concept of modulation, putting information into light and radio wave and electric signal, but let's assume they did. It's our job as engineers now to make use of it. Say, you can send bytes. If I give you a file, go ahead and send it through these fiber optic cable, and it's gonna arrive the other end. It's a wild, wild west, right? You need a standard. So what we just described is what's called the layer 1 physical layer, where we have a bunch of bits, just a string of bits, 10, 10, 0, 0, 1, 0, 0, that could mean literally anything, and we shove it into the physical medium, and that takes care of our computer, takes care of transmitting the actual driver of the fiber card or the network card or the Wi-Fi adapter, takes care of this transmission, right? But we really need other things on top to give us some sort of structure to what we send. Okay. So now I'm gonna actually jump all the way up to the final layer, which is layer 7, right? Now we understand we have layer 1, which is the physical layer, where we have a bunch of bits, understand this. That's shoves into medium. We don't really care, and we transmit it. That was the invention. And then let's go all the way up to the application layer. Think of an application layer as what you interface with as a backend engineer, as a front-end engineer. This is the HTTP example. One example, popular example, is the HTTP protocol, where you want to use the fetch command to send a GET request to your beautiful web server. So you have an IP address, or you have a domain, but let's say for simplicity you have an IP address, you have a port, you're going to port 80, you're going to this IP address, and you have your own IP address, and you have your own port, and you have the content that you're sending a GET slash. That's your GET request. Well, maybe you're sending some headers and stuff like that. All this stuff that you're sending, right? The actual content, forget about the IP and the port for a minute. This is what you're sending. You as an application layer is responsible of doing all that stuff, right? Preparing the payload, this string of data, the GET request, the headers, all of this stuff. And then you have a chunk of data, okay? Now, the next layer that comes into play is called the presentation layer and the session layer. I'm going to summarize those two because they are literally, I never seen an example where they are actually used, right? I'm going to give you the functions of what they do. We usually do the job of the layer 6 in layer 7. We just do the job in layer 7. That's why people don't like even the OSI model. They prefer the other model, TCP IP model, because we, as engineers, that's another problem. We have another problem, guys, with engineers. We try to over abstract things, and we try to create so many unneeded abstractions because we're fascinated by theory, fortunately, while the practical world is actually don't need all this junk, unfortunately. So the presentation layer, actually one application of the presentation layer is converts what you have as object, that is your programming language, into a serialized thing that you can transmit, actually. Because an example is JavaScript, because a lot of people use JavaScript. JavaScript, you have this object, JSON object, but the JSON object itself is not literally transmissible. You cannot transmit a JSON object, and people will yell at me, no, yes, Hussein, you can. Well, you can't, because it's an in-memory representation. You can only transmit a JSON object when you actually transfuse it, you serialize it into what is called a JSON string. Only then you can actually transmit it. This is a process called serialization. You serialize, and presentation layer is doing that thing, but we do it in the layer 7 because why we need another layer to do that stuff. Also, presentation layer also responsible for encrypting and decrypting and stuff. So we get this JSON. Let's say you're sending a JSON request and a GET, right? I know people will yell at me, hey Hussein, you can't really send JSON and a GET request. You can't send a body and a GET request. Well, okay, let's make it a post then. Sheesh. Okay, let's make it a post. And then you're sending a body and there's a JSON object. Well, the JSON string, which will turn into a bunch of bytes. Okay, you serialize it. Sometimes encryption and decryption, TLS, falls into that layer as well. It's also debatable. The next layer is the session layer, which maintains the session, right? Maintains the connection itself. Session 5, nobody uses it anymore, as far as I know. Is pushed down to layer 4. Layer 4 actually maintains the session, which maintains the connection, because you all know layer 4, spoiler alert, is the TCP. One example is the TCP, where it maintains a connection. It was actually a logical connection, right? So that's good. We jump into layer 6. Now, layer 5, we have maintains the connection. Let's actually jump to the actual layer 4, which is the most important layer. Layer 4 has many jobs, but let's assume we're using the TCP protocol for now, which is a reliable protocol, right? That allows us to transfer things in a reliable manner, because we just talked about how physical medium doesn't really care about your feeling. It's gonna try to transmit it, but it might reach there, it might not, right? These bits. So now we have this payload that we received from layer 7 and went through layer 6, right, which is the presentation layer. And this is this content, this post request. It goes and fall into layer 4. The first thing layer 4 does is deals with application ports. So you say, okay, what port are you going to? Right? We're going to port 80. So it adds header called, okay, we're going to port 80. That's layer 4. And also, so okay, what port are you coming from? Well, you're coming from a random port that the application decides. And you might say, why? Okay, I understand, Hussein, I understand we're going to port 80 because that's where the destination is. But why do I need a port for my application? That's for the server to know how to respond back to you. Because, honey, you're not the only one using this computer. There are many processes that need communication with the outer world. They can't just use the same port, right? Otherwise, because you guys all you're using the same IP address, right? At the end of the day, all these processes. So all these requests, that the responses that come back from the server needs to be delivered to application, and the port is the application. Think of it simply this way. So the layer 4 adds this source port and the destination port, and now this becomes a segment. So layer 4 deals with segments. Sweet. So this takes the segment and adds all sorts of junk to, right? Sequence numbers, stuff like that, right? Like, because it is like you need the 3-way handshake to do the actual TCP, but I'm not gonna have to go through it here, which I talked about many times in this channel. So you take that segment, which has the port, the destination port, the source port, and other stuff, and headers. It adds headers. The segment, the TCP layer or the layer 4 adds a bunch of headers. So all of this is just bits at the end of the day, including your content, right? Which might have been compressed by the HTTP protocol, right? Or the presentation layer. That's another thing the presentation layer does. Now all this segment goes in and then slides neatly into layer 3. And layer 3 is called the IP protocol. So we have the transfer protocol, layer 4. Layer 3 is the IP protocol. And as you guessed, layer 3 IP protocol deals with IP addresses. So now you take that segment, which has the port, the source port, the destination port, and the content, the post request, and then you add a bunch of more headers. You add the destination IP address, you add the source IP address, and other stuff as well. And you can see all these layers. Now each layer is like a Russian doll, Matryoshka, kind of a Russian doll, right, situation. Every layer adds other headers to maintain itself. So the IP protocol, the IP layer adds this stuff, and then now we call it differently because we like to confuse people. Okay, we call it packet, IP packet. So TCP segment and layer 4 IP packet. Okay, so that when I tell you an IP packet, you think of, oh, IP packet is just, it doesn't know a port. It just knows the IP, the destination IP, and the source IP. It doesn't know a port. You can argue with me though, Hussein, we'll just do deep packet inspection and I'll just find out the port. Yeah, but no. This meme, right? Yes, but no. Well, at layer 3, that's what you should be looking at if you want to follow this conceptual OSI model. At layer 4, yeah, you find the port. Right? Now we have a beautiful packet. This packet goes down to layer 2, which is, guess what? It's called the data link. And the data link, here's what I think about the data link. The data link was invented way before. And I think it's important, but I think it's something we have to deal with now. Before the idea of IP addresses and all that stuff, right, the routing capability of IP addresses, we only had computers, and each network card in the computer had a unique address called the MAC address, the media access control access address. It's a unique address. You can't find two network cards with the same MAC address. And we use that for communication. It says, hey, destination MAC, source MAC, content, right? And we call that a frame, right? So we had to deal with the same thing here, the MAC address. And now the question becomes like, what is the destination MAC? I don't know that, Hussein. I only know the IP address because I, as the application, said that. Well, the MAC address is something that your operating system finds out, right? The stack, the TCP/IP stack finds out. And basically, when you're going outside your network, it is mostly the MAC address of the router, the gateway, right? It's for MAC addresses are used for internal communication only, like for something that is tightly in. IP addresses for external, you're going outside, right? So now you take this beautiful IP packet that you have, you find out what destination MAC you can do. Okay, how do I find the destination MAC? Well, it already depends. I have only the IP address. If you're within the same subnet, you do an ARP, an address resolution protocol, you find the MAC and then you insert it there. If the IP address is not in the same subnet, you find your gateway and then you snake the MAC address of the gateway there at the destination. Okay, I'm oversimplifying it. In the actual internet, this is not how it works. I'm talking about simple local area network. Now we have this IP packet falls into nicely into what you call a frame, and it could fit in 1 or 2 or 3 frames. Who knows? Because your IP packets might be huge. You had a lot of stuff. I don't know. So it might have been broken up into multiple frames, and each content will add the MAC, the source MAC, the destination MAC, and other stuff as well. That tells you, oh, this is, by the way, an Ethernet frame. This is a Wi-Fi frame, and so on, right? Again, I'm not so versed at that layer, but that's the idea here. Now, back to the first thing that we talked about. Now we have just frames. The frames will have, obviously, the outer things will have the MAC address, which is, I believe, it's a 16 byte. I might be mistaken there. And then another 16 byte here, so 32 bit. And then you have the actual content which came from the IP packet, which has the IP address and the source IP address and the destination. And then it also, the IP packet has the layer 4 content, which is the source port and the destination port, which also have the application content, which has the actual post request, your post request, right? So all of that stuff goes down all into a frame, but the physical layer doesn't understand frames. So you eventually take that frame and just string it into a bunch of bits. 10100010, and it's bytes and bits at the end of the day, right? But you understand it, and the destination machine understand what this bits 1000 means. You shove this 100000 into the physical layer, as we talked about. If it's a Wi-Fi, we send it through radio. If it's a fiber optic, we send it through light. If it's Ethernet, we send it through electrical signal, and then eventually we'll go through the medium, and then it will reach the other physical machine. It doesn't have to be a physical machine. Reach the machine, and then the physical layer will transmit this information back from 1000 from electrical, radio, and light back to 1000. And now layer 2 is responsible to kind of assembling this. Okay, 1000, oh, stop, this is one frame. Okay, 100, oh, there is another frame. Oh, 1000. Oh, here's another frame. And then you do your same thing. You start assembling and aggregating frame. There is a bit called is aggregate in the frame that aggregates multiple frame into one jumbo frame. And that just goes up to the stack. Now we're going down, from down up, from bottom up. So we have frames. Oh, frame, what's this frame? Oh, this frame is going to this MAC address. Oh, just the router now in this case. Let's say received. Oh, frame is for me. Let's take a look. Is it really for me? It's for me from layer 2 perspective. It is destined for me as a router or as a gateway from layer 2 perspective. Let's take a look. Backs it up. And we find that there is a beautiful IP, destination IP. The IP is not for me, unfortunately. Most cases, the router, the destination IP address is never the router, right? When the router actually picks the frame, it's never for it, unless you're managing the router itself. You're going to the router web interface, right? So the router will, okay, what port though? Stop, unpack. So layer 3, we found the IP addresses. Okay, unpack more. I need to find the ports. Here's the thing. Routers usually don't go that far, I believe, because they don't need to, right? They need to go to layer 4 to do NAT, network address translation, because you need to know the ports, right? So they go to layer 4, find out so they inspect and find the ports. Which port are you going to? I need to, because you're a private IP address. I can't let you go out to the wild, scary, gruesome internet. I can't let you out there. It's a very scary world out there. So I need to NAT you. And so that's a table that the router keeps for, okay, this private IP, this random port is actually my public IP, and then it does all magic. But usually routers don't go beyond that. It doesn't need to look at the application layer unless you have some sort of firewalls in place in the router, which most routers do. So they will do deep level inspection all the way to layer 7 and then find, hey, why are you going to this particular domain? This is nasty. You don't go, right? And then obviously this goes all the way up to the application layer optionally if you want to, and then goes back down and reassemble the same story to send it to the outside world. And each machine can go up the stack, each device, let's correct that, can go up the stack up until what it needs. Like a router goes up to layer 3, technically layer 4 if it needs to do NATing. If it doesn't need to, then it goes up to layer 3. A switch, for instance, doesn't need to go to layer 3. It's not its job. A switch only looks at layer 2. It needs only MAC addresses, because it needs, okay, oh, this MAC address is actually this port. Go. Poof. Oh, this MAC address, oh, you're not supposed to connect to this MAC address, because this is another virtual network. You don't have to go there. Yes. Sit down. You don't have to go there. And then access points, I believe the same thing, right? So once you understand what's happening, every application that you build lives somewhere in this stack. Most us engineers, software engineers, we live in layer 7. That's where we live at. If you're building proxies, or if you're using proxies, you might live in layer 4 and layer 7, right? That's why there's a layer 7 proxy. What does that mean? Layer 7 reverse proxy, a layer 7 load balancer, layer 4 load balancer, layer 3 load balancers. What does that mean? It all layer 3 firewalls, all that stuff, right? It all really depends of where are you in this stack. Again, guys, this was a very brief discussion on the OSI model. Again, a lot of people don't like that particular model because it's over, layer 5 and layer 6 are particularly useless. They are not useless. They're useless to talk to us, just complicate the story. We skip them most of the time when we discuss stuff. Again, I might be wrong. Some people I know some proxies actually take advantage of the session layer, a specific session layer implementation like Linkerd. I believe they built something like that before. That they live in session, the session layer, but I don't know exactly what is that. But we usually presentation layer, we shift it to the application layer 7, and session layer, which is layer 5, we push it down to layer 4. Because why, right? And there's people who are says, okay, TCP model is just 4 layers, right? I just like, hey, is this the application? I don't, and basically the rest of the stuff. All right, guys, that is it for me today. That's what I want to discuss. Make sure to subscribe for more content like that. If you enjoy this content, subscribe, like this content, check out the podcast if you listen on the go. Now things are opening up. That's great, right? If you're listening on the go, check out the podcast, definitely. And I'm gonna see you in the next one. You guys stay awesome. Goodbye, y'all.